Okay, so now let's look at some of the basic queries. Make sure you have your correct database selected, and you can click on the SQL button here, and then you can write your queries here and you'll see the results here. So the first one, so select name from employees, then you get all the names, just one column, simple enough. Select two columns, you have to press show query. Select name age from employees, you get two columns now, name and job. And now if you want to get all the columns, then you just put the asterisk and star. So select star from employees. This will give you all the columns and all the rows in the table. So in this case, we can see the ID, name, job, manager ID, hire date, salary, commission, and the department ID. Show query box again. And this time we're going to do a select name from employee, order by name. So in this case, this will alphabetically order the results, or rather lexicographically. And remember that the execution order is from, order by, and select. So in this case, it's just alphabetically ordered. Now let's use some filters. So here we have select name from employee where job equals analyst, and then order by name. Clear, and select name from employees where job equals analyst, order by name. So here we're filtering, show the query box again. So here we are filtering for the job column, and we're looking for the keyword analyst. So we want to get everyone, we want to see all the employees who are analysts or with the job title analyst. Let's clear this, and now let's look at in between. So here we're saying select name salary from employees where the salary is between 2,000 and 3,000. And so we can see these three results here, and these three people have the salary between 2,000 and 3,000. And we can see all the rows if you want to make sure. So we can see the salary here, it's between these three records are the ones that are between 2,000 and 3,000. So let's look at the null value now. So spoiler alert, so we have the null value here already. So we're looking for the records where the manager ID is null. So it's select name job from employees where manager ID is null, and that's the record that we have. Kaylee, the president. So she doesn't have a manager because she's the president of the company. So now let's look at end. So this is select name job from employees where manager ID is not null and salary is greater than 3,000. So here we're looking for employees whose salary is more than 3,000, but we don't want to have Kaylin in there because she's the president and she's the only record with the manager ID is null. So we should get these two records here, Scarlett and Frank, and their salaries are greater than 3,000. So we can again check that real quick. So here we can see that this is Scarlett and this is Frank. So now for the OR operator, so here we can see select name job from employees where job equals salesman or analyst. So here this doesn't really give us a good answer because we are getting only the salesman, we're not getting any analysts here, which might be something intuitively you may think that you want to see the records where the job is a salesman or analyst. So what's actually happening here is the database engine only evaluates one part of the OR, and if that's satisfied, if this is true, then it just produces that result. It's not going to evaluate the second part. So to illustrate that, if we swap these two, analyst and salesman, then let's see what happens. So now we're getting only the records that are analysts, and we're not getting the salesman, because again it's only evaluating the first part of the query. So the correct way to do this is to use the in operator. So here we're saying select name job from employees, where job in analyst comma salesman, and in this case we're going to see all the records where the job is in analyst and salesman. Now that's more like it. And in a similar way we can also do a not in. So we can simply say not in, and then it'll show everything that's not analyst or salesman. So in this case we have clerk, manager, president, and more clerks. Now let's look at the like. So here we're saying select name job from employees, where name like MA percentage. So this is saying that we want to see the records where the name starts with MA and then a wildcard. So these are the two records. So we can also put the percentage in the middle. So we can do Z, and here percentage Z percentage means that we want records where there's a Z in the middle of the word. So now we have one record here where there is a Z in the middle of somebody's name. And so the percentage is for multiple characters to use as a wildcard. So if you just want a wildcard for one character, then you can use the underscore. So here you just have underscore, and in this case we will get just one record here for Frank, where we are looking for just one word instead of multiple characters. Now if you wanted to use regular expressions, it's different in different systems. So there is a syntax difference. So in MySQL you'll have to do it this way, which is a little cumbersome and unintuitive, because you'll have to use the regular expression, and then you have to put in quotes the hat symbol in the middle of the square brackets. That's where you specify the characters that you're searching for. So that's the pattern matching for the MS in the name. So you can see that there is so we're looking for either an M or an S in the name. So we're looking for names that start with an M or an S. So that's why the hat is in the front here. Now calculated fields. If you want to calculate fields on the fly, then you can just use some of the normal operators. So here we are doing select salary plus commission from employees, where name equals Adeline. So we want Adeline's salary plus commission. And here it's this is the sum of two separate fields. Concatenate. So if you want to concatenate two columns, then you'll have to use the concat and then the name of the columns. And you can also use a space here in quotes if you want to put a space. Again, this is different in different systems as well. So if you're in Microsoft SQL Server, then you can use pipes. And you can also use pipes here if you set the configuration. So MySQL has a configuration file, so you can allow the pipes operator to work. There is a setting called pipes underscore AS underscore concat. So if you turn on that mode, then you'll be able to use pipes. And usually the reason why you would do that is if you're doing migrations in and out to other database systems, then the code that you have written, or if you're importing stored procedures or views and so on, and all that code might be using a different syntax, So for compatibility reasons, they provide some tools to make life easier. So let's look at some of the built-in functions. So this is the trim function. So the trim function just trims the white space before and after. In this case, it's going to do both sides. You can use R trim and L trim if you just want to trim on the left or if you're on the right. So now here we're using an AS, so this helps us create an alias, and this alias is just for a label, so it has absolutely no meaning or anything except to make the records look pretty here. So here the results will say employee name and their job title, and then we concatenated two fields. So in this case, it makes sense to create a custom title for the column name. So let's look at aggregate functions. So select AVG salary from employees, and then you'll get the average salary from all the employees from the employees table. So that's the average salary. Now this is the count star. This is extremely popular in a lot of stored procedures and a lot of views and a lot of queries in the production world. Select count star from employees where job equals manager. So count star just counts the number of records. So here there are 3 managers in the table. So now we're getting to slightly complicated queries. So let's show the actual table data, so that will be a lot easier. Now let's see how the group by works. Select job count star as the number of roles from employees, group by the job. So here we're getting analyst, clerk, manager, president, and salesman, and then we're getting the number of roles that exist for each of these job titles in the table. So that's a job count star and grouping by the job. So now let's look at having. So here we have select job count star as number of roles from employees where salary is greater than 2000. Then we want to group by the job, and then having count more than or equal to 2. So here we're saying that we want to see the number of roles and the job from the table employees where the salary is more than 2000, and then you want to group by the job, and you want to make sure that you want the roles where there are more than 2 roles. Now we can add an order by here as well. So let's do that. So now it's the same query, but we changed the salary to 500 so we can get more records. Then group by the job, and having count more than 2 or equal to. And now we want to order by the number of roles first and then the job. Press go, and then we have analyst, manager, clerk, salesman, 2, 3, 4, 4, and we can verify here now how many of the roles there are, and you can count them as well. And subqueries. So it's select ID from employees where job equals manager, and we have 3 rows here for there are 3 managers, 1, 2, 3, and now we can use that in as a subquery. So here we want to get the name of the employees where the ID is in select ID from employees where job equals manager. So obviously we can get this in a much easier and cleaner way, but this is just to illustrate the subquery here. So here we have the 3 names of the people who are managers, and we're doing that by getting first the ID of all the employees where the job equals manager. So those 3 IDs that we first saw, and then we're constructing our SQL statement so we can now get the name of the people which match the ID from this initial subset of the result set. We can also use aggregate functions in the subquery. So here we're doing select name from employees where salary equals, and then select max salary from employees. So here we're looking for the employee with the highest salary, and that's our president here. Okay, now let's look at joins. Okay, so now let's look at joins. So here we have select employee.name as employee name, departments.name as department name from, let's format this in a better way, from employees, inner join tables, inner join departments on employees.department ID equals departments.id. So here we can see the actual columns. So this is the departments table, and the primary key for the departments table is the ID column, and this is the employees table, and the primary key for the employees table is the ID column, and the department ID here is the foreign key in the employees table, which corresponds to the departments here. So that's what we're doing here. So this is the inner join departments on employees.department ID equals departments.id. So we're connecting this and this, and then we're doing an inner join here, and we want to get the employee's name and then the department's name. And we're using aliases as well. So we want the employee's name to say employees underscore name, and the departments to say department underscore name. So if we run this, then that's the result that we get. So here we are seeing so here we can see that in the employees table there is no department name. So we only have the ID, the foreign key for the departments table. So if you want to know which department Frank is, if you want to know which department so if you want to know, for example, which department Frank is in, then by just looking at this table, we can't get that information. We only see that it's 201. So if you're one of those people who knows the codes by heart, then you'll know exactly what these numbers mean. If not, it's going to be meaningless. So in order to get the actual name, so we need to connect these two tables by using the ID field and the primary key and the foreign key, and that way we're able to get more meaningful information. Now in a similar way, we can also do a left outer join. So here, let's format this again. So here we're doing a select, the same select part, employees.name as employee name, departments.name as department underscore name from employees, left outer join departments on the employees.department ID equals departments.id. So nothing else changed, the same query, but instead of inner join, we're doing a left outer join here. Now we can see that we got this extra field here, this extra row here for marker, and we're saying that the department name is null. So there is one person here who doesn't belong to any department, and when you did the inner join previously, this record was eliminated, so we didn't see this record. So they were only, so now there are 13 so there are 13 rows here when we got this query. Now if we go back and check the previous query, now show query, and now for example if we go back to our previous one, which is just inner join, press go, and we can see that we only got 12 records here instead of 13. So that one person marker who's a clerk, the department ID is null here. So when you're doing the left outer join, you will get all the records from the left table and then only the matching records from the right table. So if we go back and do the left outer join, so here we're saying employees is the left side of the table. The employees is the left side of the join, and the departments table is on the right side of the join. So all the records from the left side table, employees table, and then only the matching records from the department table, and the matching has to be done based on this criteria here, department ID equals ID. So that's why we're getting all the records from here and then only the matching records from here. Now if we swap these two, then in this case it doesn't really work. But if there are more records here that don't match here, then we'll get all the records from this side and then only the matching records from the employees table. Now if you want to do a cross join, we can do that. That just provides us the Cartesian product. So this just provides us with all the combinations of records from both tables. So we can see that there are 56. We can see that there are 56 total records here. And it's only showing the first 25 because we have set this to a number of rows, 25. So if we put this to 100, then we can see all the records here. Now this is usually only useful in specific types of queries. It's not really used in most of the regular queries that you would be constructing using stored procedures or views and so on. Now this is the union query. So here now this is the union operator. So you have one query here and then a second select statement here. And then we're just joining both of those select statements. So let's press go. So here we're doing select name, job, salary from employees where salary is more than 3,000. And then you want to combine that with select name, job, salary from employees where job equals clerk. So in this case, we're getting a union of this select statement results and this select statement results. Okay, so here now we're inserting rows into the table. So insert into departments, name, location, and then the values, sales, and Berlin. So here we are adding a new row to this table. So we have to specify the name of the columns first, and then the values that we want to insert. Okay, now we are inserting rows into the table. So this is insert into departments. So we're inserting data into the departments table, and we have to specify the column names, in this case name and location, and the values that we want to insert, sales and then Berlin. Okay, so now let's insert data into the table. So here we're inserting data into the departments table. We have to specify the name of the columns, name and location, name, location, and then the values. We have to also add ID. So ID, name and location, and the values 5001, sales and Berlin. So this will insert one row, and we can check that here. So here we have the new row, sales and Berlin, that we just added. We can also update data in the table. For that we can use the So in this case, we can use the update, then update the table name, and then the set column equals value, and then where, any where clause that you want. So in this case, we are updating the employee's salary to 1,000,000 credits, where name equals Jonas. So that updates the row here. So let's just check that. If we click on employees now, so here we can see the much bigger value here. Now if you want to change the structure of the table, you can also do that from the GUI, but from using SQL, we can use the alter table command. In this case, we're saying alter table employees. We want to make changes to the table employees. Add, we want to add fav color, which is a new column of type varchar with 40 characters, and it allows nulls. And where do you want to place it? You want to place it after the salary column. Let's go, and so that works here. So let's click on the employees table, and we can see that there is a new column here called fav column, and there is no data in there, so it's the absence of value which is null.